Consider the following statements in respect of an estimator t for the parameter theta. So t is unbiased for theta implies t square is unbiased for theta square. So if we consider unbiased, like t is unbiased, so that means expectation of t is nothing but theta. So that means if we say expectation of theta square as variance of t plus theta square. So therefore, this does not imply expectation of t is theta does not imply expectation of t square is theta square until and unless this variance is 0. So therefore, first statement is false. And the second statement says if t is consistent for theta, t square is consistent for theta square. So if t is tending to theta in probability, so then by continuous mapping theorem, so t square is converging to theta square in probability. So therefore, second statement is correct. And the third statement says t is sufficient for theta implies t square is sufficient for theta. So this is also not true, because so generally when we do like one-on-one transformation, so a one-one transformation of a sufficient statistic remains sufficient. But if we see like squaring, so if we consider squaring, so squaring is not 1-1. So this is not 1-1 because if t is equals to x is sufficient, let's say, so then x square may lose the sign information, like for negative values will become positive. So therefore this need not remain sufficient. So therefore statement 3 is incorrect. So option A will be the correct answer.